Welcome to Jimbo's Garage.
Good afternoon, everyone. Welcome back to Jimbo's Garage. Well, this is a light fixture from a parking lot light standard. This is an aluminum housing right here. The electrical contractor had brought this to me and told me that if there was any way that I could make something that's close to this, not exactly, but they can't get parts for this anymore and they do need one more of these. What he said is not really important is this aluminum molded part of the frame right here. What is important is that this frame right here look the same, the dimensions are the same. They're going to provide a piece of glass for it. They got these little nubs on the very end. The idea is I believe they're changing out these incandescent lights to these LED type lights, and somehow or another they're missing one of these frames. What also is important is it be able to open up, hinge open, so they can replace the lights when they need to and be able to hinge close again. All right. So this is a lot of aluminum welding, something that I hadn't done in a long time, but let's see what we can put together for these guys. Let's get started on today's video. All right, so we're starting out with some 3/4 inch by 1/8 inch aluminum angle. That is what the existing frame is built from. And they also have some 5/16 by 3/8 solid bar stock on the inside of the frame as well. I just got this over at my cutoff saw and I'm cutting some angles, and I'm getting a lot of people asking me why I back up my material on the saw like that. And that's because my blade does not go all the way through when I set it at a 45. I've had a lot of viewers tell me that table does move forward and a couple of inches. There is a slot for that, and yes, I just noticed that there is. But I will probably make those changes later. But for now, that's why I use a little backup behind my blade when I'm cutting my 45s. All right, I'm over here at the welding table, and I've got everything clamped down nice and square, and just making some tacks. Now this is, some aluminum welding. I haven't done this in a long time. I like doing all the different welding processes, and I'm fortunate enough to be able to have the machines to do that, and the capability and the jobs that require all different processes, and I enjoy all of them. Aluminum comes around. Sometimes it comes in waves, and sometimes I don't do it in a long time. In this case, it's been a while since I've done an aluminum project, so I'm probably going to refresh myself a little bit here. There's going to be a lot on this particular project. But I'm starting out by just getting some tacks on the inside of this frame right here. Getting it square, getting it held together. I've got it flipped around the outside. These cuts were really sharp on a 45, and so I decided to go ahead and just fuse the outside together. That's going to work out pretty good for me on there. Nice clean job. It fuses nice and smoothly together. So I'm operating off of the HTP invertig 221 on this particular portion of the build. That is, I've got it set up with an air-cooled torch, and I'm running a number 5 cup, 3/32 tungsten, and I'm using the CK Worldwide laser tungsten, which is a chartreuse. That I've seen a few people use this. It works really good. I also like to use the E3, and also the thoriated works well too. I use them all. All right, so with that done, I'm just kind of touching up the outside right here. And the next step is to put in those little pins. Those are 1/4 inch aluminum dowels, and I would imagine what they're used for, just looking at this, is they must slip up into the housing of the light standard itself. This is one way that they slip up and then they get held in from the front by a clip. So I'm just matching the same thing as on the original light fixture. These dimensions are within a 1/16 of an inch. They're real close, and that's the whole goal here, is to keep everything exactly the same size. Once I got those dowels put in and got them driven into the right length, I just put a little tack on the inside of them to ensure that they're not gonna come out. All right, with the first part of the frame done, now it's time to put the second part in, which is this little plate here on the outside. On the original one, what they have here is a black louvered plate on the outside, because the original light had transformers, all kinds of stuff that had to stay cool, and that's what they used. There was a plate on top of that, and then the heat transferred through the louvers on the outside. In this case, we're not having that, so I'm just trying to replicate something here that's going to look the same. I also want to remind you guys that these light standards are 100 feet apart and they're 30 feet in the air, and I don't think they're going to be noticeable that much. I'm just trying to get the dimensions looking the same, so when you look at it from the bottom side, they look somewhat the same. All right, that frame is together. And now it's time to start cutting that 5/16 by 3/8 flat bar stock that I talked about. This is going to go around the whole perimeter, and I'd imagine what that's used for is some strength to kind of keep everything held together. At least that's what I'm thinking it is. That's what the original one had. All right, I got it spaced up a little bit, got it off the ground a little bit. I'm trying to allow a little bit of room for the plate that I'm going to put in there. I'm jumping around a little bit here in terms of my filler metal. This is depending on how much material I got to put in. This is some 1/8 inch filler material right here. I'm jumping around to 3/32 depending on how thick and how wide I've got to place some beads. I noticed I was using 3/32 for everything, and I got pretty big gaps right here that I'm trying to fill. That 1/8 inch really filled that gap pretty good. I like using the my air-cooled torch for smaller, lighter weight jobs. Of course, the Invertig 221 also is hooked up to water-cooled if you want as well. I'm fortunate enough to be able to have a couple of different machines. I've got one set up air-cooled and one set up water-cooled. We're going to get to that other water-cooled one here shortly. Like I said, for smaller, lighter weight jobs, that's the way I like to go. It's just you've got your single gas hose coming off. It's a little bit easier to maneuver. Water cooler, you've got 3 lines at least that are coming through, usually wrapped in some sort of sheath. And this is a flex head torch. Those are always good. They're for a little bit of flexibility. I also like the flex lock, and I've got that set up on the 313. We'll see that one here in a little bit. Like I mentioned, air-cooled is great when you're doing smaller or lighter jobs. The torch head has a tendency to get really hot if you do some longer welds, but for smaller, tighter stuff, it's a lot of the stuff I do is that way. This works out pretty good for me. And the flex head gives you a little bit of flexibility in terms of being able to move the head around a little bit and get yourself into position. I've got the machine set at about 200 amps. I'm not using all of that. Operating off the foot pedal, and it's probably about around 140 to 160 amps, depending on what I'm doing right here, and it seems to be working pretty good. Using straight argon, and I'm using about 40 CFH. Not 40. About 15 to 20 on this application here. All right, with that part of the frame done, it's time to start moving on to the molded section or the center section of the frame itself. Now you can see I've got a piece of 1/8 inch aluminum flat plate right here, and I'm using the Evolution metal cutting saw for that. This thing really works good for cutting sheet metal, aluminum, cuts really nice. The disadvantage is you can see the chips are just everywhere. They go everywhere, and that's the same thing with my cutoff saw, the cold saw. The same thing, chips fly everywhere. That's a disadvantage. The advantage is they cut really good and really fast. I've just made some cuts there, and then I've switched over to my portaband. This is some 2-inch flat bar stock. This is what I needed, so I didn't want to cut the sheet metal out of that. I happen to have some flat bar here, already 2 inches, and that worked out pretty good. All right, this is the basic frame to that to the outer light box, or whatever you want to call it. And you might see that I've offset the two pieces that are on either side right there. They're not perfectly square. They're about an 1/8 inch off, and that's there for a reason. I know that you guys are going to say, hey, you're not lined up. Well, I'm not lined up for a reason. This fits inside the frame, and I needed that extra 1/8 inch on that one particular side to kind of lock it into position. It's hard to explain, but that's why it's that way. So that wasn't a mistake. That was intentional. All right, everything clamped down nice and flat. I found that the more clamps you get and the more flatter you get everything, it just seems to stay that way. If you guys know, if you don't clamp things down, you put this much heat into, sometimes you get a lot of warping, deflection. But clamping everything down seems to help a lot to stay a lot flatter. All right, over to the portaband and trying to trim some things up here. Now, this is just something, there's no rhyme or reason of this box that I'm making. Like they explained to me, it does not have to be looking like that molded thing. The idea is just to be able to get the actual light itself inside the fixture and have some clearance. The rest of this is going to be up inside of a housing, and it's never going to be seen. So I've just kind of cut this. I believe these were 6 inches. 6 inches tall, and I'm just kind of raking them back on a little bit of an angle, just using this, I'm not certain what you call it there, a little angle finder or whatever, that's what I want to call it, and just clamped everything down and came up with this angle. And I'm not certain what that angle is. It's just something visual at the time, and I just repeated the same thing here on the other side as well. For now, just a couple tacks on everything to hold everything together, especially on this part of it. And in case I've got to make some adjustments, bending in, bending out here and there, to make everything come together on all 4 sides. All right, with those 2 sides in, this is the other 2 sides. Took me a little bit of time to get everything lined up perfectly square and clamped into place. But once I did that, then it was time to just go ahead and just tack everything in. I had to do a little bit of bending, a little bit of flexing. But once I got it lined up pretty good. You guys might see me wearing these gloves. These are short cuff TIG welding gloves. Got these from Black Stallion. I kind of like them. It gives you a lot of maneuverability, with the short cuffs like this, rather than having long cuffs. I just seem to like them. I've been using them for about a year or so now, and it's just something that I like when I'm TIG welding. Funny thing, see that clamp I got at the very top, on the top right there. If you're lucky, on a good day, every once in a while, at the Home Depot, those things are on sale for 99 cents. And every time they do, I usually grab 2 or 3 of them, and now I've got a bucket full of them. Don't use them every day, but when you need them, you need them. For 99 cents, you really can't go wrong. All right, all tacked together there. All we got to do is put the lid on the top, and then we're ready to start assembling. Well, you can see how nice and easy that saw makes. Of course, it is aluminum, but actually it cuts just as well with sheet metal. All right, so I'm clamping the lid in. This is just another cool thing that I've got from weldtables.com is this adjustable clamp right here. Not only does it adjust on the vertical, but it also adjusts on the horizontal position as well. Those things come in handy for a lot of different things, when this is just a good example of that. I needed to stretch out a little bit farther and get up a little bit taller, and I was able to do that with these clamps. Flip it around, do the same thing on the other side, and we're going to be all tacked together and ready to start the big welding process. All right, so I've been operating off the HTP invertig 221 AC/DC, and now I'm switching over to the 313, the invertig 313 AC/DC. It's a newer machine that I acquired earlier this year. This one I've got hooked up to the water cooler, and since I'm going to be doing some long continuous welds right here, that's what's going to help out a lot, keeping that torch head nice and cool. All right, so on this one, you'll see that I'm using the CK Worldwide Flex Lock torch head right here. This one here is pretty handy for all kinds of different angles. If you can't get yourself in position properly, it helps to be able to maneuver that torch head around and get it bent in a position that's going to work for you. I'm also using a number 5 edge clear cup on this, and I believe I'm bouncing back and forth between the 3/32 and the 1-inch filler rod. Whatever seems to work. This is just another thing. Like I've mentioned earlier, I don't do a lot of aluminum welding. In this particular case, I hadn't in a long time. So something like this is it's not absolutely perfect. Originally, I thought I was going to be able to just do some 1-inch kind of beads all the way around, but the more I thought about it, is the light is actually going to be inside this box, and I didn't want any light transferring through any of the gaps, even though it is going to be in a housing. I still thought that it would be best to go ahead and seal everything off, and so I decided to go ahead and just seal it all off. And I added it up. It was somewhere around 8 to 9 feet of continuous welding. And you can see that those aren't A plus, but there are no holes, and it's filling the gap and it's doing the job. So, the more you do, the better you get at it. And for me, I can't really go more than about 2 or 3 inches at a time before I need to stop and kind of readjust myself. And what's helped me out a lot is the TIG finger there. You can see it for a number of reasons. One, it just keeps everything nice and cool. And 2, I'm able to just kind of guide along there and slide along there nicely without getting hung up. And that worked out pretty good for me, a situation like this. It was a bunch of welding, that's for sure, but I was able to get through it. Now this project right here, this believe it or not, it probably took me about 3 weeks. Now, not 3 weeks of continuous work, a couple hours each night probably in the shop, and it was a lot longer than I thought it was going to take. But the farther I got along with it, the funner the project got, and to see this thing coming together and looking like something gave me a great deal of satisfaction. All right, you see this right down the very end right here, and I've got myself propped up with a 4x4 block. That always helps too. The more comfortable you get, the better it is, at least for me. And I believe this is the last run on this whole thing. And it just seems, like I said, here it is, the last run. I'm finally getting the hang of things a little bit, and here it is. It's all going to be over. Actually, I'm getting about 3 or 4 inches before I need to reset myself. You see all those leftover pieces of rod I've got sitting there? Now I haven't showed that, but what I will do, and I do this a lot with my rods, and I don't know if it's a good thing or a bad thing, but it's hard for me to just waste that. So I ended up tacking them all together and creating one more stick and using it where I can use it. I didn't show it here in this video, but I have in past videos. All right, there it is. That's a bunch. That part of it's all done, and we're getting really closer to seeing this thing coming together. Okay, so with the regular frame right here, the original frame, and then I've got an interior angle iron frame, and then the flat plate that goes in there, and then this part of the light that goes inside the inner frame. And now it's time to start doing some assembly. So for this little plate right here, all I really need is probably 6 tacks all the way around to just hold it in place. That's all I'm doing, is just trying to hold it in place. It doesn't do anything other than that. Tight welding, tight spot right there, big gap. And switched over to some 1/8 inch right there to get a lot of filler metal in there. And then I jumped around to the inside, and this is where I'm welding the box to the inner frame that I made. And then that frame, we're going to put a hinge on it, and that portion of it we'll be able to hinge open. We'll get to that here in just a minute. You know, the angles are starting to get a little bit tight in here for me. And this is where that flex lock comes in handy, to be able to make some adjustments in the head and kind of bend things around to get it in there. Got a little stubby end cap on there as well. I probably could have gone to a smaller one in situations like this to get it actually more tighter in there, but it seemed to work, so I'm just going with it. All right, with all that welding done, it's time to get the hinge assembly put on. All right, and for the hinge assembly, this is some aluminum piano hinge, 1-inch aluminum piano hinge, and this stuff is really thin to work with, so it's really got to be careful with this. You can burn through it real easy. Keep the heat on the thicker part of the material for sure, and just let it flow up in there, and be sure you get everything clamped really close together. It has a tendency to pull away. At least that's what I noticed. So I'm just not welding it all the way across, just about about an inch or two bead every couple, 3 or 4 inches is all I really want to do. That's all you really need. All right, that's working pretty good there. Couple little spacers to get spaced up where it needs to be. And it's time to get the other side of the hinge welded in there. This is what's going to hold it in place. Got these small little finger clamps from Clamps Plus. They're ideal for small stuff like this. They work pretty good, especially in this situation. The other clamps got a ruler about an inch round head on them, and they couldn't quite get on there to hold this down. All right, there it is. All right, so now for the the locking assembly, or the latching assembly, I should say. The original one had some sort of a latch on there. I'm not going to go with that. I'm going to go ahead and make this. This is some 1/8 inch aluminum angle, some stuff that I had left over, and I'm just going to create a latch type where I can just weld it on something like this, and then I'm going to drill and tap through it and put a little finger screw in there. It's not like they're going to be getting into these lights, every week. This is something that's probably going to get into once every 5 years to replace the lights. And I think this finger screw is going to work just well. I mean, I couldn't find a matching latch that they had on the other one, so this is the route that I decided to go. A little finicky, a little bit of adjustment there for sure. It's not something that I had to work with it as I went along. You can see I'm just trying to get everything clamped into place. And at some point here, I decided I needed to put a spacer back in behind there to give it a little bit of space, and that's what this is for. I wanted to be sure that it opened and closed freely without binding at any point. Autofocus. Wow. All right, so something like that. And this is a 1/4 20 finger screw is what I'm going to put in there. I got the other side done as well. Getting a little excited. Got to the very end, kind of burned through the back on this one a little bit. Not a big deal. I'm not going to worry about that too much. I suppose I could have got in there and tried to clean that up a little bit. You can see I tried that, and it's starting to get worse. So I thought I'd just leave well enough alone. It's plenty strong. Got a weld on both sides there. All right, like I said, this is a quarter 20, so this is the number 7 drill, and I'm going through both of these right here. And you know, it's ironic that I hang on to everything, and so I went over to my bolt bin after I got this tapped out and was able to find a couple of thumb screws that were actually the perfect size thumb screws. You know, you hang on to everything and you know you're going to use them one of these days, and that's the case here. I just opened up that first hole a little bit, and then that's the way that's going to work. All right, well, there it is. It is complete. That was quite a project. Took me a long time, but it's functioning the way it's supposed to function, and ultimately looking the way it's supposed to look on the very bottom. There's the original right there. They will be putting the glass in there, and they will be putting the light fixture in as well. Side by side, and the most important thing is the underneath side, and this is what needed to be seen, and that's what it looks like. So when the glass goes in, you shouldn't be able to tell what these things look like if they look much different from 30 feet in the air. This is a great project. I hope you guys enjoyed watching it. A little bit of aluminum work, a lot of aluminum work. All right, thanks for watching, guys. Don't forget to check out my website, jimbosgarage.com. See you guys next week.
See you next time on Jimbo's Garage.